Sorry about that, guys. I apologize for the interruption. Where we were at was we were just calculating, right, the length of our line segment LN. So we had just gotten that we wind up with 8 minus 2, which is 6, and 6 squared is 36. We were working on this one where I have 1 minus 7. 1 minus 7 would be a negative 6, but then you square it, right? So a negative 6 squared is going to be 36, right? Yeah, I get 36. Take the square root of all of that, which means that ln, 36 and 36, how about 72? Again, 72 is not a perfect square. That's okay. Remember, we're going to compare the two lengths. Just go ahead and convert it to a decimal. I get 8.48 when I put the square root of 72 into a calculator, 8.48. Let's compare that to PQ. Here we go. PQ, we wind up with, well, I think, again, we can probably do this in our head. 9 minus 6 is going to be 3. 3 squared, 9. Plus 5 minus 8. Well, 5 minus 8 is going to be a negative 3. But that negative 3 is going to be squared. So a negative 3 squared, again, is going to be 9. We wind up with PQ being the square root of 18, which I can approximate using a calculator. The square root of 18 is 4.24. Now again, remember the question is this. The property says that PQ, the midsegment, should be half the length of LN. Is it? Well, 8.48, divide it by 2, and sure enough, you get 4.24. And so yes, PQ is 1/2 the length of LN. So that's the way that a couple of these problems can go as far as midsegment is concerned when I give you a coordinate plane, plotting out those triangles and midsegments on a coordinate plane, and then showing me that the midsegment and the third side are parallel lines, and that the midsegment is half the length of the third side. Guys, head on over to the next page of the notes. We'll take a look at a couple more problems involving midsegment. I'll meet you there.